this is Kolmogorov equation. We have just entered this one, the continuous times stochastic process. So when we talk about Kolmogorov equation here, there is a small derivation. We'll use the derivation. I'll do the derivation also because that we'll use frequently. This one we have seen already. This is not a new one. Kolmogorov's equation, Chapman-Kolmogorov equation. We have already seen this one. We use this one. Here we talk about states I to j. So I to k and then k to j. I to k, here the time interval is from m to, suppose you need to go from I to j. I is Delhi and j is suppose Chennai. You have to go from D to C in 5 hours. 5 hours means suppose from 10 to 3 p.m. Okay, that way we divide and then we multiply the probabilities. What is the probability that you will go from Delhi to Mumbai, then Mumbai to Chennai, that way. So we have two probabilities, then different ways all k belongs to x we explore, and when it's homogeneous we don't write specially the starting time and the end time. We just write the difference. Instead of writing 10 to 3, we write 10 to 1, that is 3 hours here. See, this is the notation. So we can write the difference. Instead of writing the starting time and the ending time, we can write the difference here. 10 to 1 we will not write, we will write 3. Even that 3 also, here in this chapter, we write this way. There is always a bit of confusion when we talk about the symbols. T plus n s when it's written here, you see invariably in this chapter, this was from the earlier chapter, we use the same symbol in a different way here. I can write p I j, this one, n minus m here. If m is 0, then this will be n, that way. So the total time is given n minus m here. Suppose you start from 0 instead. M is 0 here, 0 to n, 0 to L, L to n. So 0 to n, the time gap is n here, the time gap is t plus a here. Okay, so let me write n here. This is n, and that is equal to L, 0 to L. Suppose n is 5, this is 3 and this is 2. 0 to 3, 3 to 5, that way. Okay, so 3 hours and 2 hours. But if I write this way, I to k here, suppose L, that's fine. But the second one, when I write k to j, here L minus n, n minus L will come, right? So the difference here. So if you add L, n minus L, that will be n anyway. But if you write this way, it will be easier to remember and understand. So in this chapter, we use this way. Instead of writing a single one, you write 2, t plus s here. And then the first time like L here and the second time t here. So what will happen is, we need not write n minus L. So we have just changed in a way we like, and that will be even easier for derivation. Remember, this is the Chapman-Kolmogorov equation. This is also equation. From equation, we will go to differential equation. And you will know later, maybe tomorrow, why the differential equations are so important. We'll start with this one, Kolmogorov equation only, but not this form, this form. They are one and the same. That's what I wanted to say you. So this is the Kolmogorov equation, p I to j t plus s. This is t plus s. The time given is 5 hours. 3, this is 3 hours, then 2 hours, 5 hours. In 3 hours, you need to go from I to k, and in another 2 hours, you need to go from k to j. That's what given. Okay. Here also I mentioned this one. Now this was already there. This is the Kolmogorov equation, but here in this chapter we'll derive Kolmogorov's differential equation and then integral equations also in some classes. let me write the definition here, definition of mu ij. But before going to that, let me write here new one. Let me write the notation that we'll use in this chapter. So remember, this is very important. D upon dx fx, when we write, this is actually limit h tends to 0 fx plus h minus fx divided by h. Here h tends to 0. This is the definition of differentiation, the rate of change of a function with respect to x. So when x changes from x to x plus h, there is a small change. You see the functional value. The functional value is fx here, fx plus h here. So for a change h here, what is the change in the function? Any function. In commerce we talk about sales figures. In physics we talk about the distance traveled. In chemistry we talk about the chemical reactions. Okay, so what is the amount here, what is the amount here? When we talk about the disease, the change in the amount of virus from time to time. Okay, so there is a small change here. Within a small change, what is the change in the function? The difference you find and divide. This is the difference. I can write this is x plus h minus x. Here x changes from x to x plus h. This changes from here to here. So in a small time, if you want to know, you write h tends to 0. So in a small time, we see the change. That change is important. Because why we talk about small time? If you remember, in 11th class physics, we talked about this. Suppose in 3 hours, somebody moved from here to here, 120 kilometers. So what will happen is, when you find average velocity, we say 40 kilometers per hour. But that's not true. If you see the instantaneous velocity, it might not be 40 kilometers per hour. It could be 2 kilometers per hour. This is instantaneous velocity. But this is average velocity. They are not matching. That's why this failed. When we write s upon t, v is s upon t, this is the average velocity. But if you want to know the instantaneous velocity, we write ds upon dt. Because instead of taking a very large interval per hour, we say, we will not see this. We can't use this one for this purpose. Okay. If someone is watching here on a tree and watching whether I'm traveling with this kilometer or not, at this point, I might not be traveling at 40 kilometers per hour, because this is a very small time. In a very small time, the change you have to watch. So you have to see near to this one. Instead of 1 hour before, 1 hour after, we see very near to this. Maybe very near to this, you will see if it's decreasing 3 kilometers or 5 kilometers, and here it's 1 kilometer. Okay, some hindrance is there. Your speed decreased here, then it might increase. So instead of long intervals, you are taking shorter interval. That's all in differentiation, nothing else. So we use this notation, the derivative notation. And particularly we are interested the change around 0 here. So not only d upon dx fx, but also around x0. We'll check the rate of change of f of x around x0. That means any function operating, we'll see the change around here. Means here how it's changing. We are interested here. We are not interested how it's changing at other points. We are interested to see the change here only, nearby 0. So we'll replace it by 0. That will be limit h tends to 0. You take this as 0. fh minus f0, the value at 0, the value of function at h which is very close to 0 divided by h. This kind of notation we'll use here for our derivation. So let me start the derivation. We need another also. This is one. The second one is mu ij. Mu ij. There is a link between Pij and mu ij. The definition of mu ij is d upon dt Pij. And remember, although we can write t any point here, because we are talking about homogeneous, we will not worry about whether that point is 0. We are seeing the change around 0 or 1 or 2. We are not worried because it's homogeneous. The changes will not be different. So by definition, we have considered this one, mu ij. Mu ij is different from Pij. When we talk about mu ij, these are the transition intensities, and the definition is the rate of change of probabilities around t0. So this is the probability Pij. This is the probability we talked here, Pij t plus s, Pij t suppose. That means I to j in time t. Here 0 t, you can write I here, you can write j here. What is the probability that in time t will move from I to j? That is the probability. And around t0, mu ij is differentiation of Pij, the rate of change of Pij around time t0. And we will see how mu ij and Pij are connected. This is the mathematical definition. Later we will apply in problems, and many problems come also. There are 15 marks, 20 marks like that. They are connected, very interesting and practical. But yeah, we'll start with this simple definition, then we'll move forward. Now see here, we'll apply this notation here, this notation particularly, not the former one. So let me write this: limit h tends to 0, Pij h minus Pij 0 divided by h. I have never seen they have asked this in the exam, particularly UK exam. Rarely it must have come in India exam, once maybe, I don't remember. But yeah, the definition, this is important because without this we will feel the results will use absurd. Okay, so this divided by h. Delta ij is a notation for Pij 0, that's all. So what is Pij 0? If you go here, Pij t, if I say Pij 0 here, what is the probability that you will go from I to j in 0 time? So time given is 0, from here to here only. This is 0. What is the probability that you will go from I? You are at I, so you will be at I only, right? So at this time only, there is no way you can move to j if j is different from I. So P, unless I is equal to j, is impossible. So this is 0 when I is not equal to j. When I is equal to j, this is 100%. This is delta ij, notation we use here. Delta ij is Pij 0, that is actually 1 when I is not equal to j, 0 when I is not equal to j. There is no way. You are here means you are here. If j is some other state, suppose I am teaching now and I want to be at some other state at the same time, how it's possible? Though the state is different. Suppose I'm reading a book, a novel, I'm watching TV, that's another state, my other state. Suppose I go through 5 states in a day. Now I'm teaching in the teaching statements, I'm in the teaching state. So if they're different, what is the probability that I will move from teaching to watching TV in 0 time? Now only, it's impossible that way. Now this is Pij 0 is 0 or 1, for that we write delta ij. So mu ij is equal to this. Now when I write A is equal to limit h tends to 0, anything, suppose B I need to write. So what will happen is, I am getting A because there must be some terms which are vanishing when h is going to 0, and then I am getting A. So B must contain A for sure, plus something which is tending to 0 when h tends to 0. So what we write is, in that case I can write, suppose I can write limit h tends to 0. In B, A must be there. First of all, if I write this B must be equal to this A plus anything that's going to 0. I can write order of h by h, because by definition when you take this limit, A is there, and by definition order of h by h tends to 0 when h tends to 0. So you get A. So if you get A from limit h tends to 0 B, then B should be equal to this one, because when you substitute B this one and you let h tend to 0, then by definition limit h tends to 0, order of h divided by h is 0, you get A. So here if you see this one, Pij minus delta ij divided by h is equal to mu ij plus order of h divided by h. What will happen is, suppose I want to get this one, let me do like this. So here I will write limit h tends to 0, that is equal to limit h tends to 0, so this will be 0, I will get this one, that is what? Okay. We are doing the reverse process actually here. Now this we know, then we cross multiply Pij minus delta ij, that should be equal to h, multiply here h mu ij plus order of h, then Pij will be equal to delta ij, that is 0 or 1, h mu ij plus order of h, then Pij h will be equal to either this is 0 or 1, h mu ij plus order of h, when I is not equal to j, this is 0, okay, this is 1 when I is equal to j. So this is something we'll remember, and it will take another 3 minutes to complete the derivation. We'll use everywhere, very important. So let's continue further. Remember, we started with mu ij, now we'll go to mu ii. Mu ii, that is limit h tends to 0, Pii the same thing, I'll replace j by I here, Pii minus, okay, we'll use this one, Pii 0 by h. Though we know this now, Pii 0, we need not write delta ij. Even delta ij is also not required, but yeah, whatever way it is, I've written. So this Pii 0 at 0 time going I to I, that is 1. This is 1. So limit h tends to 0. I'll write this as 1 minus summation Pij minus 1 divided by h. Of course, I need to write j is not equal to I. Okay, because what will happen is either I to I or some other thing. It's like this. If this is I and then this is j, so this probability plus this probability plus this probability is equal to 1. So what is the probability that it will go from I to I? Total probability is 1 minus all these probabilities, because if this is 0.2, this is 0.5, this is 0.3, I am writing 0.5 is 1 minus 0.2 minus 0.3. 1 minus this is summation. This is what we have written here. J is not equal to I. When j is equal to I, you will get this 0.5 left hand side. So this one is equal to this one, and this is 1, so this one and this one, they will get cancelled. The summation you can take it out. It's like this: limit h tends to 0 a plus b is equal to limit h tends to 0 a plus limit h tends to 0 b, this way. So if you write limit here, then this is summation of limit, right? This is limit of summation. This one is summation of limits. Limits ai, you can write a1, a2, two limits, a2, a1, a2, that way. So I will take limit out. Yeah, derivation is over. Mostly this much derivation you need, and then we'll apply, and you will see it will be very, very clear to you why all this derivation equal. The summation you take out minus summation Pij, okay, sorry, limit Pij divided by h. Now there is no more 1 here, though minus is here. Then I can write Pij 0 when I is not equal to j. Okay, here ii was there, ii 0 is 1, but ij when j is not equal to I, because this is j is not equal to I have written here, so this is 0, so I just added here 0. So again this is the derivative form, right? See here, this one exactly I will take this one. This is mu ij. I got mu ij. I mean this one is mu ij. So exactly I got this one once again. So this is mu ij. So mu ii is equal to minus summation mu, this with limit, this is mu ij. This is what I wanted to derive. This is a very important result. Throughout this chapter we will use. See how mu ia, this is the only derivation. I don't think you will get this in the exam, but yeah, you see this will use frequently. Minus j is not equal to I mu ij. This means when I write the generator matrix, I is not equal to j. This is my generator matrix, and this is transition matrix. Here we write the probabilities, and here we write intensities. These probabilities we discussed in the in previous classes. We'll be continuing with this. Then we'll connect also. These things will connect. Mu 3.1, mu 3.2. To connect all this, we need Kolmogorov equation. I'll discuss extensively tomorrow how Kolmogorov equations are used. But before that, Kolmogorov differential and integral equation should use. Now here we use Kolmogorov's equations only. But to connect these, we need Kolmogorov's differential and integral equation. Now, coming to this, there is a result. Here also, we always wrote P11, P12, P13, summation P1, J is 1 to 3 is 1. Even for all I, for each I, summation Pij, J is 1 to 3 is 1. For I 1, 2, 3. So this summation is 1, this summation is 1, this summation is 1. We use it in many problems. Now in this chapter, we'll use this plus this is 0, because what it says, mu11 is equal to minus mu12 plus mu13. That means this one is minus of this plus this. What is mu22? This element, that is minus mu21 plus mu23. This plus this. How about mu33? That is equal to mu31 mu32 minus of mu31 plus mu32. So when you add these two, you will get this one. Here, if you sum up everything, that should be 1. Here it's 0. That means mu11 plus mu12 plus mu13. If you add 3, that should be equal to 0. If you add these 3, that is 0. If you add these 3, then that will be equal to 0. Here it's 1. If you add all, here you will get 1, here you will get 1, here you will get 0. That comes from this derivation. This is what we derived, and it will be very useful. We'll use all the time. Many times it will become a practice later. This is important. Now we'll see one example. If you consider this example here, a Markov jump process has two states with transition rates as shown in the diagram. Write down the generator matrix of the process. Unlike the earlier diagrams, you will never see a self-looping here, because that is not required. Here, this is the generator matrix. Let me write state 1 and 2. State 1 and 2 here. Always this will be given 0.5, 1 to 2, 0.5. This is not the probability once again. This is transition intensity, mu22. I can write mu1 to 2, that is 0.5. This is given. Mu11 will not be given. You will never see a self-looping here, because that is 0. We are not talking about probabilities from state this to state this. So this is 0.5, 1 to 1. 1 to 1 we can always find. This is minus 0.5. If it's not given in the earlier diagram, that is 0. I mean in the previous chapters. Now here this is the sum is always 0, so 1 will be given only. So 2 to 1 is 1.2, 2 to 1 is 1.2, so 2 to 2 will be minus 1.2. Again, if you want to know logically what is the meaning of minus 0.5, yeah, that will be cleared in some time. When you do problems, through practical problems, you will see what is the meaning of minus 0.5. And remember, these are the rate of change of probabilities. These are not probabilities, these are intensities. So if I want to write mu11, because the total is 0, so this should be minus 0.5. So self loop will not be given anytime, you have to find. Now let's come to this one. When you write the generator matrix here, the matrix of transition intensities, if you write healthy, the other one is sick and dead, healthy, sick and dead. So healthy to sickness intensity is given. I think that is sigma, and dead is given mu. We already used this one, healthy to dead mu, force of mortality in CT5. And this one will not be given. You can write here mu plus sigma. Then similarly, S2H is given, that is rho, and S2D also given, nu, so minus rho plus nu. Similarly, D2H is not there, D2, this is not there, this is not there. Again, if you sum up all the things, it's 1. What is the meaning of D2D? If you think in terms of probabilities, it should be 1. Someone is dead, the probability that after one time period someone will be in the dead state 100%. But what is the rate of change? That is 0. The probability is 1, but the rate of change is 0. That means, suppose we are talking about people, they are dying each day due to different problems. So suppose 10 are here in the dead state. All they come this way to the dead state, whatever. Now what we are saying is, what is the rate of change from here to here? So if someone is here, there is a 100% probability that one will be dead. So the rate of change is 0. I mean, it's 1 in terms of probability. From here to here, there is 100% probability that if one person is in dead state, he will be in dead state. But the rate of change is 0. Okay, that's what it says. So generator matrix will be important when you form equations here, and using generator matrix, we'll form equations, and tomorrow we'll start with Kolmogorov's forward equation, forward differential equation. We'll start with this one, we'll do some problems, forward differential equation. 4 equations we need to study. I'll teach you 2. 1, 2, both are differential equations. Equations already we know. Then we'll do differential equations. Then we'll do integral equations. Here also I'll do one, the other will be similar to differential equation. Differential equation, there are 2, forward, backward differential equation, forward integral equation, backward integral equation. So this is another chapter. So once you complete these two will be similar. Yeah, there is something we'll do. These two are at least similar. So once I'll complete tomorrow this one you can do. I'll say you how to do all this, and then you can do a lot of problems after doing all this. So see you tomorrow. Class is over for today.
Thank you so much, sir.
Okay, fine. Bye.